In your textbook, they have the situation with just one, and they say permutations of identical objects. If you have n objects and r of them are identical, so the example that they have is Pee-wee. You have 6 objects. Normally, that could be arranged in 6 factorial ways. But because the e's are identical, you would have to divide by 4 factorial for all the different ways that you could imagine those e's differently. Whew. E, that E, there we go. Maybe that's, I don't know if that's an E. If you had those 4 different e's, it would be 6 factorial. But since they're all the same, you have to divide by 4 factorial. But this permutations of identical objects can get extended. I sometimes call these like questions like, right? It seems to be the favorite word that everybody spells in elementary school. Then you remember doing that? I know how to spell it in Mississippi. Maybe not. But in Mississippi, normally if all the letters would be different, so these types of identical object questions, you would count how many objects do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Normally it would be 11 factorial. But then what's identical? I have identical eyes. How many of them? 4 factorial. Those are your eyes. What else do I have identical? S's. Another 4 factorial. Those are your S's. Anything else repeated? Your P's. There's 2 P's. Could you divide by 1 factorial for the m? Yes, but it wouldn't do anything because it would just be dividing by another 1. So when you type this into your calculator, it's probably good to use a fraction button, or if you're typing it in all at once, since you have more than one thing in the bottom of your calculator, you would put brackets around that. So here's the idea. So far, we've only talked about the idea with words and letters that have repeated themselves. What we're going to see in the next couple of examples is where else could you have identical objects. And if you have identical objects, you have to recognize that in the question and use this as a strategy. So let's look at example 1. There are 7 cereal boxes on a shelf. 5 boxes are bran, 1 is puffed wheat, and the other box is granola. How many ways can the boxes be arranged in a row? So first of all, we recognize that this is a counting question because it says how many ways. And we want to arrange different objects. So it's normally a spaces question or a permutations question. We have 7 things. If you were trying to arrange 7 different things in a row, you could do 7 spaces, and it would be 7 factorial. But in this one, we recognize that 5 of the boxes are bran cereal. We have 5 that are the same. If we wanted to show this using letters, this would be like B, 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 puffed wheat, granola. So if your parents happen to name you as your first name, and you wanted to make a new internet password using the letters of your name, well, how many could you do? Normally it would be 7 factorial, but we have 5 identical objects, so we'd have to divide by 5 factorial. And this is something I want you to look at and do the mental math. You ready? Got it? The answer? $42. How do you do that in your head? Well, with factorials, what's the definition of factorial? 7 factorial, 7 times 6, and it keeps going down, right? So if I wanted to show my work, can you say that instead of writing 5, 4, 3, 2, 1, I could just say, oh, at 5, it's going to be 5 factorial. That's going to simplify with that 5 factorial. And then I have 7 times 6. That makes 42. So if you can do that part mental math-wise, you can see why it's equal to 42. Okay, questions for practice. 3 to 6. Have a look at some situations where there's identical objects.